minus the square root of 36 minus 40 will give you minus 4 all over 4. So x is equal to 6 plus the square root of minus 4 all over 4, or x is equal to 6 minus the root of minus 4 all over 4. This is a case of unreal or imaginary roots. So, because we're getting a negative number under the square root sign, we say that the roots are unreal or that the roots are imaginary. Now remember, the word roots and solutions means the same. Alright. Okay, so here we have number 5. 5x squared minus 2x minus 3 is equal to 0. So we're going to identify A. A is 5, B is minus 2, C is minus 3. We know that we have to use formula here. Once I write that there, it means it does not factorize. X is equal to minus B plus minus the square root of B squared minus 4AC all over 2A. Minus into, what is B? B is minus 2. Plus minus square root of B squared minus 4 into A into C. All over 2A. All over 2 into A. So B is minus 2. A is 5. C is minus 3. A is 5. So that's plus 2. Plus minus the square root of 2 minus 2 squared will give you 4. Minus and minus will give you plus. 4 5 is 20. 20 times 3 is 60. Oh, this works out perfectly. Alright, no need for corrected two decimal places, because this is going to factorize. Yeah, it factorizes. Alright, never mind. So there's no need to work this out, corrected two decimal places, because this one actually factorizes. Right. All over 2 times 5 is 10. So it's 2 plus minus the square root of 64 all over 10, which is equal to 2 plus minus 8 all over 10. Now, let's just check this up carefully. There's 5, x squared minus 2x minus 3 is equal to 0. Let's check the question. If the original question was like that, that's correct. Right. So there's no need for corrected two decimal places here, because it actually factorizes. But let's say you didn't know how to factorize it, you use the formula. And let's see what happens. So there you are, you substituted and so on, and you came up here. So your two answers are x is equal to 2 plus 8 over 10. So you get 2 plus 8 over 10. Or x is equal to 2 minus 8 over 10. Right, so that gives you 10 over 10, which gives you 1. And that gives you minus 6 over 10, which is minus 0, comma 6, because it works out exactly, no need to approximate. Minus 6 over 10 will give you minus 0, comma 6. Alright, so there we are. This one will factorize if you try to factorize it. But if you felt that no, it can't factorize, you don't know what the factors are, you just use the formula and you get the answers. Alright, but just out of interest, this one factorizes as follows. If you try to factorize this, 5x squared minus 2x minus 3 is equal to 0, then the factors are 5x and x. and then you write your minus 3 here and plus x. No, minus 3 there and plus 1 there. So let's see if it's correct. 5x squared, yes. Minus 3x. Now you put your plus here and you put a minus here. Right, there we are. There's the factors. You see, it factorizes 5x plus 3 into x minus 1. That's 3x, that's minus 5x minus 2x. Yes. So if you didn't use the formula and you went and factorized this example, you'll get 5x plus 3 is equal to 0, 5x is equal to minus 3, x is equal to minus 3 over 5, x, and when you put minus 3 over 5 in the calculator, you're going to get minus 0,6. Or x minus 1 is equal to 0, x is equal to 1. So here's an example that could be done both ways. Right? There was no need for correct to 2 decimal places because it works out to exactly an exact answer. Alright, so that was number 5. Alright, so you've got this example here, and then you realize that you got to cross multiply. So x minus 7 times x minus 7 is equal to 5 times 5. That's x minus 7 all squared is equal to 25. Now, you can do this the way I showed you before, or what I'm going to do now, I'm going to show you a new method from here. You see, if you got x squared is equal to 9, for example, suppose you got x squared is equal to 9, then you can say that x is equal to plus minus the square root of 9, x is equal to plus minus 3. Let's suppose you had an example like this, x squared is equal to 9. Then you are allowed to say that x is equal to plus minus square root of 9, which gives me plus minus 3. That means x is equal to 3 or x is equal to minus 3. So just like that, instead of x squared, now you got a bracket squared. You see, instead of x squared, you got a bracket squared. So you can say, well, look, x minus 7 is equal to plus minus the square root of 25. Instead of 9, I've got 25. Instead of x squared, I've got bracket squared. So in this step I wrote x, therefore in this step I must just write bracket. In that step I wrote plus minus root 9, therefore in this step I must write plus minus root 25. So I get x minus 7 is equal to plus minus 5. Now what am I saying? I'm saying that x minus 7 is equal to 5 or x minus 7 is equal to minus 5. You see? You're saying x minus 7 is equal to plus 5 or x minus 7 is equal to minus 5. So I wrote that down. So on this side you get x is equal to 7 plus 5, x is equal to 12. X is equal to 7 minus 5. If I take the 7 across, it becomes plus. X is equal to 7 minus 5, 2. So final answer x is 2, final answer x is 12. Alright, so that was the answers to question 6, and that brings us to the end of the basics of quadratics. And if you know these basics, you will be able to handle whatever questions you get on quadratic equations. Alright, so the next step we're going to move on to lesson 4, and that will be solving some quadratic and linear equations together. But this is where we round up lesson number 3. Hello there, welcome once again. Now we're moving on to lesson 4, Now, may I again remind you that don't try to learn all these lessons on one day. You should learn maybe lesson 1 in the morning, and then maybe lesson 2 in the afternoon, and then maybe lesson 3 the next day, and lesson 4 the following day. Don't try to learn everything on one day. Unless, of course, you're coping, you're understanding, you're feeling good, and getting everything right, well then it's great. Now, let's see what's happening here. You are being told, solve the following system of equations simultaneously. Now, you've done this kind of things before. So when you've got two equations and you want to solve simultaneously, one of the things that you can do is take one equation and put into the other equation. So, that's one of the ways you can do. Take one equation and put it into the other equation. So if you study these two carefully, you can see that if I call that equation 1 and if I call this equation 2, you can see that equation 2 is written very nicely and neatly, and you can actually substitute this part into equation 1. So if you have to do it, this is what you'll do. You'll take equation 1, y is equal to x squared plus 5x plus 6. And then what you will do, you'll take equation 2. You can see that it is written y is equal to 3x plus 6. That means where there is y, I can actually write 3x plus 6. Because what I'm doing, I'm putting, let's write it nicely, I am putting number 2 into number 1. This is number 1, this is equation number 1. So, since y is equal to that, it means wherever there is y, I can write 3x plus 6. So there's y. I can write 3x plus 6 because y is equal to that. Is equal to x squared plus 5x plus 6. Now I'm allowed in maths to bring everything from the right hand side to the left hand side. And I'm allowed to take everything from the left hand side to the right hand side, and no sign changes. See, I'm allowed to bring everything from the right hand side to the left hand side, and to take everything from the left hand side to the right hand side without any sign changes. And then I can now see a quadratic here. So it's far better for me to bring this to the left hand side and make it into standard form. You see, I'm bringing them to the left hand side. Then I've got x squared. Now I've got plus 5x and I've got minus 3x. So that will give me plus 2x. You see, plus 5x and minus 3x will give me plus 2x. Plus 6 and minus 6 cancels off, and I'm left with 0. Now when I look at this, I've got a quadratic and I can factorize it. X into x plus 2 is equal to 0. So x is equal to 0, or x plus 2 is equal to 0. This one is solved already, and this one gives me minus 2. So what are we saying? We are saying that, look, we're solving these equations, and there are two values for x. Therefore, in the end, we'll also get two values for y. So, we move on to that side there, from here, and we're saying that when x is 0, when x is 0, y is equal to 3x. Y is equal to 3x plus 6 becomes y is equal to 3 times 0 plus 6. Y is equal to 0 plus 6. Y is equal to 6. In other words, the first ordered pair we get is 0 because x is 0 and y is 6. And then in the second case, when x is equal to minus 2, when x is equal to minus 2, y is equal to 3x plus 6 becomes y is equal to 3 into minus 2 plus 6, which is minus 6 plus 6, which is 0. In other words, in the second case, we're saying that when x is minus 2, y becomes 0. So, we have solved the system of equations and we have come up with two values for x, we have come up with two values for y. And we write the answers usually in an ordered pair. There's x, there's y. When x is 0, y is 6. When x is minus 2, y is 0. Alright? So that is how you solve. And you can see now, this is why we learned quadratics, because we're using the knowledge of quadratics to solve this problem. Let's do another example just to get the system right. So if you look at this 2 here, I can call it equation 1, I can call it equation 2. And what I'm going to do, I'm going to put number 2 into number 1. So just draw a little line there to separate the work. So y is equal to x squared minus 9. But you can see that y is equal to 3x minus 9. That means where there is y, you can write 3x minus 9. So 3x minus 9 is equal to x squared minus 9. Now, I'm allowed to write x squared minus 9 over here, and I'm allowed to take all that to the right hand side. Everything from the right hand side to the left hand side, everything from the left hand side to the right hand side, with no sign changes. No signs are changing. Now, I'm trying to bring it to standard form. There's x squared, there's minus 9, minus 3x if it comes on this side, plus 9 if it comes on this side, 0. And then I've got x squared minus 3x minus 9 and plus 9 gives me 0. Once again, I can remove common factors. X into x minus 3 is equal to 0. X is equal to 0, or x minus 3 is equal to 0. X is equal to 3. So I got my two values for x. I got x is 0, or I got x is equal to 3. Now, I take these two values and I can put them anywhere I like, in number 2 or number 1. It's better for me to put it in number 2 because there's less work. So I'm going to put them in number 2. So now what we're going to do, we're going to put into number 2. We're going to put x equal to 0 in number 2. We're going to put x is equal to 3 into number 2. So we do it step by step. We say that when x is 0, y is equal to 3x minus 9 becomes y is equal to 3 times 0 minus 9, which is 0 minus 9, which is minus 9. So, what are we saying? We're saying that when x is 0, y is minus 9. When x is 0, y is minus 9. And then we take the second case. When x is 3, y is equal to 3x minus 9 becomes y is equal to 3 into 3 minus 9, which is 9 minus 9, which is 0. So what are we saying? We're saying that when x is 3, y is 0. So we can write the answer as an ordered pair like that. Alright, I think you've got a feeling now of how to solve equations simultaneously, and you can see that in these examples you are using your knowledge of quadratic equations to solve these problems. Alright, so I'm going to give you 2 little examples to do now, and you can try them and then I will mark them for you. Alright, so here we have exercise 1, solving simultaneously, 2 examples. In number 1, solve simultaneously y is equal to x squared plus 2x minus 8, y is equal to minus 2x minus 8. And example 2, y is equal to x squared plus 2x minus 8, y is equal to x minus 6. So you've got 2 examples that you need to solve simultaneously. 2 different examples. Alright, so what you can do now is stop the DVD, try these examples, and then switch on again for us to help you to mark them. Alright, so there's example 1, and you want to work that out. So when you read the question, you will say put 2 into equation 1. You'll put equation 2 into equation 1. So let's write equation 1 down. Y is equal to x squared plus 2x minus 8. So if you're going to put number 2 into 1, then where there is y, you will write 2x minus 8. So you got minus 2x minus 8. You'll write that because that is what represents y, is equal to x squared plus 2x minus 8. Then laws of equation allows me to rewrite this whole thing on the left hand side, and I can write this whole thing on the right hand side without making any changes. So I don't make any changes. So I've got x squared plus 2x minus 8. Now I bring the minus 2 onto this side. Now I bring the minus 8 onto this side. So the minus 2 became plus 2, the minus 8 became plus 8. Now I'm left with x squared. Now plus 2x and plus 2x gives me plus 4x. Minus 8 and plus 8 gives me 0. So I'm left with x squared plus 4x is equal to 0. Remove common factor x. X into x plus 4 is equal to 0. X is equal to 0, or x plus 4 is equal to 0. That is solved already, and this says x is equal to minus 4. Now we move on to the next step. We found the 2 values for x. We've got to find the 2 values for y. Alright? We've got the 2 values for x. Now we're going to move across to find the 2 values for y. So we say that when x is 0, y is equal to minus 2x minus 8 becomes y is equal to minus 2 into 0 minus 8. Y is equal to 0 minus 8. Y is equal to minus 8. So we now found a value for y. So what we are saying is when x is 0, y is minus 8. And now we look at the next example, or the next value, when x is equal to minus 4, y is equal to minus 2x minus 8 becomes y is equal to minus 2 times Now x is minus 4. So I must put minus 4 there. Minus 4, minus 8. That's plus 8 and minus 8. That gives you 0. So now you've got y is equal to 0. So finally what we are saying is that when x is minus 4, when x is minus 4, y is 0. Alright, so that was number 1. Now what we have to remind you here is that don't think it will always work out 0, 4, 4, 0 and so on. X can end up with any two numbers, y can end up with any two numbers. Alright, but basically this is a principle and this is how it is done. Alright, so let's move on to example number 2. On the board now we have example 2. Y is equal to x squared plus 2x minus 8. Y is equal to x minus 6. And we are trying to solve them simultaneously. Once again, we're going to put 2 into 1. Look, we can't talk like this. We can say put 1 into 2. We can do that. It doesn't mean you have to put 2 into 1. You can put 1 into 2. So let's do it like that this time. So there's 2. Now you're going to put 1 into 2. You can see that y is that. So it actually saves you some work. Y can be replaced by x squared plus 2x minus 8. You see, y can be replaced by that. Because now I'm putting 1 into 2. And there's your x minus 6. In fact, it is smarter to do this because there's less work now. So I put 1